Hey friends, I decided to do a video on how inverters work. Now have in mind, when I look at the inverter board, it is a bit intimidating, and I'm gonna be honest, I don't know everything there is to how inverter boards work, but I am gonna teach you 3 things that you can do to make sure that the inverter motor is working properly and that the voltage and the hertz are also working properly. So yeah, there's a lot of terms that I'm gonna try to teach you in this video, but at least you're gonna be able to do 3 things when you face an inverter, right? So inverters, that's the new thing that are coming up, at least with your package units and split systems now. This technology already exists in your mini splits, but they're starting to push that more for residential, light commercial, trying to push it because it is energy efficient, but we need to understand how to work on these boards. Now, just before we go there and I show you the 3 things that you can check, just to kind of show you, right, or at least talk about it. Here in the United States, electricity, volts alternating current, right, it travels back and forth 60 times a second. If you go to other countries, it's 50 times a second. It's different. But this is the idea behind an inverter, which is crazy. So, and we're gonna see it right now with this furnace. It's taking 120 volt, and you're neutral, right? This is single phase power, right? Right, single phase power, right? Single phase power. And it goes through a rectifier, so it converts the AC to DC. And it uses diodes to do that. And then it goes through capacitors to smooth out the DC voltage. If you can see the capacitors there. There are the capacitors right there to smooth it out. And then it goes through an inverter circuit. Basically, it uses transistors, fast switches to convert it from DC to AC. Now, this AC is kind of a simulated AC voltage. So you understand that as we check the motor right now and the inverter. So single phase power, but it comes out as 3-phase power powering up a 3-phase motor. So that is crazy how this technology, it does that. And so this is the idea behind inverters, because you can manipulate the hertz. And if you can manipulate the hertz, you can manipulate if the motor is gonna work faster or slower, the compressor is gonna pump more or pump less. So running at a lower speed, lower hertz, and lower AC voltage going across the inverter's 3 wires, which I'll show you right now. Running at a higher speed, higher hertz, and then higher AC voltage going to the inverter's 3 wires, which I'm gonna show you right now, okay? Okay, so I'm gonna show you 3 different ways that you can check if an inverter is working. So hertz, AC voltage, and resistance. Whether you're working on this indoor motor that is an inverter, or a compressor that is an inverter with 3 wires, and typically it'll be U, B, W, this would be the same concept, okay? So sometimes mini splits, they do have inverter technology, but they do use motors in a different way. Although they're inverters, sometimes you have a feedback wire and a signal DC voltage going to it. So specifically, this inverter is typically talking about when it has 3 wires, like you see right here, okay? UVW. All right, so let's go ahead and do hertz first. So what did we say? In the United States, 60 hertz. Volts alternating current. It's going back and forth 60 times a second. But we just said that an inverter can manipulate the hertz. The more hertz, the more it's doing work. The faster it's, at least with the blower motor, the faster it's spinning. The lower the hertz, the less work, the less it's spinning, okay? So right now, you have to have a meter that can read it in hertz. So you see HZ. So go to that. Press select. Okay, we have hertz right there, hertz, and you can get any wire. You see, it's all going to be the same. So 63 hertz, right? 63 hertz. I have it on the red one. Check the white one. Okay, you see, 63 hertz. Check the black one. Okay, that was the red and white, 60 hertz, and then the black one, yeah, 63 hertz. They're all the same. So all the 3 wires, they should match exactly the same when it comes to hertz, okay? So it's operating at 63 hertz. you're gonna see how this number changes when I change the speed of the fan, okay? But 63 hertz. Okay, what about my AC voltage? So you do need the skinny lead, and it does get a little bit complicated here, or at least tight, if anything, but it has to have it on AC voltage. Okay, let me go ahead and get closer. You got the 3 wires in the back, so you got a white, a black, and a red. So this is the key, and let me go ahead and get that in there first. Okay. All right, so I want you to see this, and I always have a hard time doing these here. Just give me 1 second. Okay. All right, and I'm gonna write this down. So it was about 63 hertz. I'm gonna write that down on the whiteboard. Between the white and the black, you see, 95 volts, 96 volts AC. 96 volts AC between, I repeat, between the white, between the red and the white. Okay, so now I'm gonna check, so that's the red and the white. Red and white, 96 volts. Now I'm gonna check red and black. Red and black. I'm gonna put it on this lead over here. Red and black, 94, 95 volts, right? So 95, 96 is within range, right? But we'll put 95. Okay, 95. And now I'm gonna check the red and the white. Okay, give me 1 second. There we go. 95 volts, okay? Okay, so that's what I wanted you to see. With an inverter, when you check all the wires to each other, the AC voltage is going to be the same, okay? With an inverter, the hertz between all the wires, right? It was 63 hertz, 63 hertz, 63 hertz. We got white, red, black. When you check all 3 of them to each other, you got 95, 96 volts. 95 between the white and black. Between the white and red, 95, 96 volts. And then between the black and red, 95, 96 volts. So it's all the same. That's the number. That's the idea behind this. With the AC voltage, they're all going to be reading the same. If it's really different, where it's 95 and 105, 95, and then 85, there's something going on with the inverter board. It should be pushing out AC voltage at least the same for all 3 wires to each other. Even on the hertz, they should all pretty much be the same. Okay? So I went ahead and wrote that on the whiteboard. This is what I want you to see. Look at that number change. So interestingly, this is an ECM. So you see, right there, those are my speed tabs that come here. So instead of these wires, which is your low voltage for your ECM, instead of it going to your ECM motor, or your motor, right, your indoor motor, is going to this inverter. So whatever speed we have it at, the inverter voltage is gonna respond appropriately. So right now I have it on the low speed. So you see I had lower voltage, lower hertz. Look what's gonna happen when I have it on a higher speed. So all I'm gonna do, I'm just gonna trick it, right? I'm gonna go ahead and remove that purple wire here. It's gonna turn off. Okay, it turned off, and you see right there, I turned it off, so that AC voltage is dropping until it goes to 0. And then of course, my hertz, if I check hertz right now, you see, I'm at 0. Okay, I'm gonna go ahead and introduce this other red wire here. It's just a faster wire here, faster speed. Okay, now let's give it a second for that AC, for that inverter to start working. But look, I want you to see right here, I'm gonna put it on hertz, okay? I put it on a faster speed. Look at that, look at the hertz increase. Look at the AC voltage increase. So let's give it a second. So I just put it on a faster speed, okay? On a faster speed. Give it a second. We just exceeded 95 volts, right? You saw that filters kind of just go up. There's more air. Okay, give it a second, because we're gonna see what's going on the whiteboard right now. Okay? Where is it stopping? It's stopping right there. So you see 158 volts, and then my hertz, 95 hertz. it went from 63 to 95 hertz. So now the motor, I can hear it, is ramping up faster, is pulling more amps, is doing more work. So that's how inverters work. It's looking for a signal so that it's got to know whether to ramp up or ramp down. But when it comes to just checking it, because I ramped it up, you saw that AC voltage, when I check all the wires to each other, they're all going to be the same AC voltage, but it's higher. So more AC voltage is going, right, to that inverter, and my hertz increased. So that's the one thing I want you to understand from today's video, is that when it was at a lower speed, lower AC voltage, lower hertz. It's working, but it's running at a certain speed. The moment that I increase the AC voltage and the hertz go up, the motor ramps up even faster. And at least on this inverter board, it does that because what I did specifically on this one, you see that red wire right there? The purple wire is your low, for your ECM, that is the low speed. What I did, I put the red one, which is a higher speed. So then that red one, this plug right here, the red one receives 24 volts, and the inverter works accordingly to that speed now, and it increased it, right? So when we go back over here, let me go ahead and get some numbers. Okay, so you see right here, I know it's not the best drawing, but just gonna show you, or at least the best penmanship. But right here, okay, when I was checking, when it was running at a lower speed, 63 hertz, and then when I checked all the wires to each other, about 95 volts AC, it was doing work. When I put it on the higher speed, right, it was 151 volts, all wires to each other. I know I didn't check it, but it's gonna be the same, right? Black to red, red to white, white to black, 151 volts AC, and my hertz increased. So if the volts is higher, hertz increases, it's working more, right? And that's the science behind inverters. It manipulates the hertz. The higher the hertz, the more it's gonna be ramping up, the more work it's gonna do. So that's inverter technology for you. And so that's how you would check it with AC voltage and with hertz. Okay, so now we're gonna check the third way, which is check hertz and AC voltage. Now we're gonna check resistance. To check resistance, we need to have the power off. I want you to know something though. I'm gonna go ahead and disconnect that. After I disconnect that, I want you to see how that inverter still has power. So boom, I just disconnected it, but you see, you still got some lights flashing right there. You gotta wait a couple seconds, you know, before everything discharges itself. You have to be a little patient. On that manual for this, because this has another inverter board right here, it actually tells you to check 2 pins, and once that DC voltage drops a certain number, then you can safely touch it. So it's important you don't touch it right away because you can get shocked. So the third way is checking resistance. So we just said that these three wires go to your motor. So I'm gonna go ahead and remove that. Okay, I have it right here with me. Okay, so now we're gonna check the inverter's resistance. Remember what I said? This is a 3-phase motor. So let's go ahead and check resistance. So you don't want to read open line, okay? Obviously, we don't want to read open line. I have it on resistance, okay? So we got 3 wires, right? Red, white, black. Let's check the first one. Red to white. You see, what do we read? About 3.5. 3.5. Now red to black. Red to black. 3.5. And now black to white. Give it a second. There we go. About 3.5. I know it's moving, but 3.5. A 3-phase motor, it acts just like a 3-phase compressor. When you check all the wires, right? UVW, it's not common run start. For inverters, they use UVW. It's just a 3-phase motor. They all have to be reading the same resistance because it's a 3-phase motor. You do not want to read open line, or you don't want to read where, let's say you read 3.5 right here, and then over here you read 1.5. Something's going on with that motor. So we all read pretty much the same 3.5 from all the, red to white to black, and then black to red, 3.5. That motor is good. And that's how you check compressors as well. That's how you would check the 3 wires on a compressor. If you see 3 wires, that's how you would check when it comes to resistance. So mini splits too, they do typically have 3 wires, and you would check it the same way. Just have in mind, some of the outdoor fan and indoor fan of mini splits, they don't have 3 wires. Sometimes they have like 5. Some of it is power, and some of it is feedback wire, and some of it is DC voltage going, so it can manipulate and speed it up or speed it down. And to be honest, I have to definitely read information on that. I'm sure it's not hard. Once I get that down, I'll create a video on that. But you see, this is how you would check it with resistance. They all have to be reading the same resistance when you check all the wires to each other. Inverter technology is awesome. Well, let me take that back. When you first see an inverter board like that, yes, it is a bit intimidating. But we were able to see in today's video 3 different ways that you can check if the motor is okay and if the inverter is doing its job. That motor there acts like a 3-phase motor. So when we checked all 3 wires, the resistance, they all have to equal or be pretty much the same. If you get open line or the readings are really way off from each other, there's something going on with that motor. The inverter board, the AC voltage from all 3 wires, right, from each other, they should be pretty much the same. If it's really way off, different than AC voltage, something's going on with that inverter. The hertz, all the lines were pretty much the same in the hertz number. And then you're able to see how when we ramped it up, the AC voltage increased and the hertz also increased. So yes, inverter, you'll start to see that more and more now, but it's not really new technology. It has existed. And guess where? Mini splits. Most of you have troubleshooted, installed mini splits. They have inverter technology. But now you're going to start seeing that more on split systems, some package units, because it saves energy. Think about it. If I live in a house and let's say I have a call for cooling, the set point is 70 degrees and inside of the house is 75. That system is going to turn on 100%. Your typical conventional system is going to go from 0 to 100%. And it's only 5 degrees away. A system with an inverter, it knows by measuring temperature that it's only 5 degrees away. Instead of turning on the compressor 100%, maybe it'll do 40 or 50%. You see, you're saving energy. So that's the nice thing about inverters. Before I go on a rant here, but I do want to explain one more thing is, what do you think, or how do you think inverters, specifically mini splits, work when you're outside? Let's say you have a call for heating and outside your house is 20 degrees. So you got a mini split, you're calling for heating, and outside your house is 20 degrees. How do you do that? Well, if you're calling for heating on a heat pump, your outdoor coil is your evaporator, right? And your indoor coil is the condenser. So we know that we need heat transfer. That evaporator needs to absorb heat, but how can it absorb heat from 20 degree weather? This is where inverter technology comes in. So we know that evaporator temperature needs to be lower than 20 degree ambient temperature. So guess what increases? If you said hertz increases, you got it right. Hertz increases. So think about a compressor. A compressor, when it turns on, your suction and your high side, your suction drops, your high side goes like this. If you increase the hertz, your high side is going to continue going up. Your suction is going to continue going down. So as you drop the suction pressure, you're also dropping temperature. So maybe it'll get to the point where your evaporator temperature is 10 degrees and your ambient temperature is 20. You're gonna have some heat transfer. That evaporator is gonna be able to absorb heat because it's 10 degrees. It's gonna be able to absorb heat from the 20 degree ambient temperature. But because the compressor's hertz may be increased to 130 hertz, you drop that suction pressure really low. And technology is just moving forward so fast. Now they have this thing called liquid injection cooling, where it takes a little bit of your liquid refrigerant from your liquid line and it injects it to your suction line, reading temperature off of the discharge line using a thermistor. I mean, it's crazy. Technology just keeps advancing and advancing, but that is why it's important that we as technicians continue learning, continue looking for that information. It's out there. If people have invented this, that information is out there. It's up to us to try to find it, make sense of it, ask questions, and sooner or later we'll be pros in that subject. So I hope that today's video helped you understand how inverters work, and I'll catch you on the next one.